Hi, and welcome to the very first, or the very least, blurst devlog for Encardia. I'm calling this one 0 because I didn't really want to start this yet, but after watching a talk from Linus Tech Tips where they speculate over a cool game idea brought about by the advances in AI, I decided I'd have to announce something.
Essentially an MMO that is entirely populated with AI agents.
Like imagine a permadeath RPG, but your effects 100% remain.
And there's this butterfly effect where someone comes in, murders the son of some AI agent baker who swears vengeance on every player character.
So then
and this
there's
town
like a plague put through the town through the bread sold at the bakery.
There could just be many potential big baddies that form
There could be forces that are aligned against each other, and then through natural events of them, wanting to gain position on each other, big baddies just are created dynamically in the world.
Those of you who may have actually paid attention to my ramblings in previous videos might be able to spot the similarities in what they spoke about. My aim for Encardia is to have the persistent world that actually turns with or without the players, but also responds to a player's actions in a meaningful way. But more than just an advanced AI system, the quest system operates differently to tradition, in that it doesn't treat the quest as a pass or fail scenario. Instead, it relies upon a consequence outcome. The quest will have a task to do, and depending on how or whether it's done, the consequences will impact the worldscape in different ways, which will then feed into generating the next step of the quest. But I've already spoken about this across a bunch of other videos, so for the first devlog, I actually want to go over some dev. Initially, I wanted a very action-orientated controller, something that allows a more casual combat experience, but also allowed for complexity for longer-term play. I'd gone with a top-down or isometric perspective to lean to that casual brawler element, but I felt that with some other mechanics, I wanted to have more fine accuracy controls that an over-the-shoulder third-person experience would bring. So after a restructure, I started to develop a prototype controller. With the help of a co-developer, we were able to make a solid controller that can handle multiple movement types. And over the top of this, I started layering subsystems to handle my desired combat. But prototypes are ugly, and after staring at my low poly models, whilst I love the jiggly outfits, I just didn't think that their aesthetic worked in the up-close perspective. So I wanted to check out my stylized toon characters. But there was a big problem with this, which stopped me using them when I first bought them, and that was that the customization was all handled by layering textures over a skin. This was handled originally by C# scripts as part of a character editor, but that would bake the texture and output a prefab to be used in the editor to create your characters. Having played another indie title on Steam and seeing these models using pre-baked prefabs, I knew this was not going to work for me. So I devised a solution, one that would involve me slamming my head into a wall and learning Unity ShaderGraph. As ShaderGraph had been around for a little while, I decided I'd actually give coding with ChatGPT a go. First I tried coding a shader manually, but after a few iterations of failure, I turned to ShaderGraph, and experimented with a few different methods using Unity tutorials. Whilst I got close, I got stuck on a bug where my layers would either tile or smear across the rest of the texture. This took me all day searching for random forum posts until I discovered the issue. For some reason that's still unclear to me, the texture sampler in ShaderGraph struggles with images that don't have blank or empty pixels around the border when working with an offset. After modifying the 150 or so textures individually by expanding the canvas size uniformly to make the blank space, and then readjusting the new offset, I was able to get the system to work. By running the texture layering in the shader, I can now modify the individual characters dynamically by swapping textures and in some cases meshes without needing to rebake the texture. Hooray! Now as this is multiplayer, the logic for switching can be server authoritative without needing to actually switch the textures on the server. I can achieve this by using a library held on the client. A request to change is made to the server verifies it, and then tells all the observers to conduct the change based on the library value. For observers that weren't around to see the change, the value can be stored and passed through when the player gets in range. So now my characters have more detail, despite retaining the stylized toon aesthetic, which I think is more pleasing to watch for a longer play period. I'll also be further adjusting the shader at a later stage. As it's unlit, I'll need to play with making faux shadows that can change with the different lighting effects. In the next episode, I'll talk about the World Manager and how I use ChatGPT to assist with making an in-game calendar system with a day-night cycle and 14-day weeks. Feel free to subscribe to keep informed, and if you have questions about the shader, let me know in the comments below.